about this. So up to here, these are all the concepts which we had covered in our yesterday's session. Am I right? Right? Okay. Now today we are going to discuss about internal architecture of JVM. All right. Just let me try to keep it like this. Internal architecture of JVM. Okay. Now, just a second. Okay. Now, guys, when you're speaking about internal architecture of JVM, first we are supposed to have an idea about class loader. First, we are supposed to have an idea about class loader. Okay, we'll discuss that. Class loader. After that, how many memory areas are present inside the JVM? 5 memory areas are there. Okay, let me just try to go with like class area, heap area, stack area, PC registers, and native method stack. Native method stack, STACK. Native method stack. These are all the 5 memory areas which are present in our JVM. And along with these 5, when you are speaking about next concept is EXECUTIO and execution engine. In execution engine, we are having actually 2 separate concepts. Let me just try to keep it like this. In execution engine, we are having 2 things, 2 completely different concepts, guys. By the way, just give me a minute. 1 and 2. Two things. First one is interpreter. Second one is garbage collector. 2 things in execution engine. Basically, there are 2 things: interpreter and garbage collector. Just let me try to keep it like this. Now, by the end of our today's session, we'll be able to understand all these particular concepts. So first, we are supposed to have an idea about class loader. Now, what this class loader will do, like what is the work of class loader? Guys, class loader, it is actually going to perform 3 tasks. 3 tasks. What are those? Loading. First one is loading. Second one is initialization. First one is loading. Second one is initialization. Third one is linking. Third one is linking. Loading, initialization, and linking. As simple as this. These are the 3 works which were done by the class loader. We'll do one thing. Let me just try to keep this linking here and initialization in the last. Okay, 3 tasks. These are the 3 tasks which were done by the class loader. So what it is going to load, what it is going to link, what it is going to initialize. We are supposed to have an idea. Now, guys, one more time. Listen, concentrate. Right now, we are discussing about internal architecture of JVM. You know that JVM is actually a virtual machine, right? It is responsible for running our Java program. You already know that if we want to see the output of our Java program, how many tasks we need to do? Two tasks. What are those? Compilation and run it. Compilation will be carried out by the Java compiler. Running will be taken care by the JVM. Right now we are discussing about internal architecture of JVM. Before JVM, on top of JVM, we are having a component known as class loader. Right now, we did not enter into the JVM. Right now, we are about to enter into the JVM. Before JVM, first we are having a small component, just a small component known as a class loader. Class loader. Am I clear with this? Respond. Now, this class loader, it is actually going to perform three tasks. What are those? First one is loading. Second one is linking. Third one is initialization. So we need to understand what it is going to load, what it is going to link, what it is going to initialize. All right. We'll do one thing. For example, let me just try to have two classes here. Okay, two simple normal Java classes. I'm having a method void method1, and here system.out.println, system.out.println. Just I'm trying to have a class A method. That's it, not more than that. Okay. Now I have a question. Can I call this method in class B? Yes or no? Can I call it? Okay, tell me first what I need to write. Don't immediately respond. Think and respond. First, what I need to write inside class B. That is perfect. What I need to write? Main method. Why we need to write main method? Come on, without writing main method, we cannot. Come on. Without writing main method, we cannot compile or run. We cannot run our Java program. Without writing main method, we can compile. Compilation will done, but you cannot run it. One more time. Without writing main method, we cannot run our Java program. Am I clear with this? So first, let me just try to write my main method. All right. Public static void main string array args main method. Now, inside the main method, please tell me what I need to do. What is my requirement, by the way? Tell me what is my requirement. What is my requirement? I want to call method 1 in class B. Tell me what I need to do. I have written main method. Now tell me inside main method what I need to do. I'm sorry. Create an. You tell me the code. I'll write the code. New. Perfect. New. Class B. Class A or B? Perfect. A. Class A. And I just want to have a reference here, guys. Please. AOBJ belongs to class A. Perfect. Now please tell me. Tell me AOBJ dot method 1. That's done. Okay. Window, show, view, console. And let me just try to execute my program. Right click, run as Java application. And I'll be able to get my output, that is class A method. Yeah, this is fine. This is cool. Now my question is, right now, class A is present in this pack 1. I mean, com.pack1. Now my question is, if I delete this class A, listen. If I delete this class A, am I able to execute my program? Can I execute class B, or else am I going to get an error? I'll be getting an error. Let us just try to check that. Okay. Right click. I am deleting class A.java. Delete it. Let me check it. Delete it. And am I getting an error here? So without class A, can I execute class B? No. Are you saying that class A together? Yes, somewhere. This linking will be taken care by the class loader. Now, please tell me how many actions will be done by the class loader, guys? Three actions. What are those? Loading, linking, initialization. Just now we discussed about linking. Means whenever you are executing a Java program, your class is connected with any other classes. That linking will be taken care by class loader. Now, guys, this is important. Please listen clearly. Listen clearly. Please listen clearly. What is the command compilation? Java space file dot Java. After class which will be dot class which is created. If you want to run, we need to a dot class file as an input to the JVM. Am I right or wrong? What is the command for running? Java space generated dot class file. Now listen to this point clearly. Whenever you are running your Java program, of course, with the help of the command Java space generated dot class file, the dot class file first it will be accepted by the class loader, not directly into the JVM. Your dot class file first it will be loaded into the class loader. Once it's loaded into the class loader, it is going to link its dependent classes. For example, are you understanding the point? For example, I am trying to run class B. I am trying to run class B. Whenever I am trying to run class B, first that the dot class file will be loaded into the class loader. In the class loader, whether the class is having any dependent classes or not. Is class is having any dependent classes? Yes or no? What is that? That linking also will be carried out by the class loader. First, it will be loaded and then the linking will be happening. Are you understanding the point here, guys? Please respond. Now, guys, one more time. Whenever you are running your Java program, first the dot class file will be loaded into the class loader. Class loader is going to accept the dot class file, and inside the dot class file, like if you are having any connections, if you are having any links with the remaining classes, the linking also will be carried out by the class loader. And that particular process is known as linking. Now, please tell me, how many actions will be done by the class loader? What are those? Linking and initialization. Three actions: loading, linking, and initialization. Loading before JVM first the dot class will be loaded into the class loader. Linking, if your Java program is having any connections with any other classes, that linking also will be carried out by the class loader. Sir, what do you mean by initialization? Okay. Before going to that, just let me try to get my class here. Okay, and here I just want to. So see, right now there is no error, right? Because I am having my class, not at all. Okay. Now initialization. What do you mean by this initialization? Okay. Now three actions. Class loader is going to perform three actions: loading, linking, and initialization. You already know what do you mean by initialization. What do you mean by initialization? Assign a value. What do you mean by declaration? Creating a variable. Yes. Did you know the difference between declaration and initialization? Okay. Now listen this clearly. Guys, in Java, basically we are having three types of variables. Three types. First one, instance variables. Second one, static variables. Third one, local variables. One more time. How many types of variables are there? Three types. What are those? Instance, static, local. Instance variables, static variables, and local variables. So very soon, maybe in 1 week or below, let's say we're going to discuss this. Instance, static, and local variables. Not all trouble, but right now, I just want to say one small point. That is, all variables except static variables. Tell me, how many types of variables are there? What are those? Instance, static, local. I'm not speaking about static variables. I'm speaking about instance variables and local variables. Initialization will be done, means memory will be assigned to these variables whenever you are running the program. Now, guys, here you need to concentrate correctly. Please tell me. You know, if you want to see the output of our Java program, how many tasks we need to do? Let's see the screen in response, please. How many tasks? 2 tasks. What are those? Compilation and running. Compile time is different, run time is different. I hope you understand the point here. Compile time means compilation will be carried out by the Java compiler. Run time means running will be carried out by the JVM. Compile time is different, run time is different. Am I clear with this? Respond. Now, please tell me how many types of variables are there? Three types. What are those? Instance, static, local. Now, I'm not speaking about static variables. What are instance variables? What are static variables? What are local variables? Guys, as of now, just the names. Let's don't go for more. Just the names as of now. Three types of variables are there. Instance variables, static variables, and local variables. I'm not speaking about static variables. I'm speaking about instance variables and local variables. Now, listen to this. For instance variables and local variables, memory will be assigned at runtime. Whenever we are running our program only, at that particular time only they will be initialized. You already know what we mean by initialization. Initialization means assigning a value. Are you understanding the point here? One more time. One last time. Please tell me how many types of variables are there? What are those? Instance, static, local. For instance variables and local variables, memory will be assigned at the time of whenever you are running our Java program only, at that particular time only memory will be assigned. In simple statement, instance variables and local variables will be initialized whenever we are running a Java program. Done. But when you are speaking about static variables, listen to this point clearly, guys. When you are speaking about static variables will be initialized whenever we are loading the .class file. In simple statement, static variables will be initialized at the time of class loading. I'm not speaking about compilation. I'm not speaking about running. What I'm speaking about loading. Guys, compilation is different, running is different. Between compilation and running, we are having loading. Loading will be taken care by the home. Timing. Yes, load. Are you understanding the point here? One more time. Static variables will be initialized at the time of class loading by the class loader. Did you understand the point here, guys? Now, please tell me. Class loader. Tell me, how many actions will be done by the class loader? What was loading, linking, initialization. Initialization means which variables class loader is going to initialize. Which variables? Come on. I'm sorry. Static variables. Tell me how many types of variables are there? How many types? What are those? Instance, static, local. Instance variables will be initialized at the time of, sorry. Static variables will be initialized at the time of. Static variables will be initialized at the time of class loading. One more time. Please tell me. Static variables will be initialized at the time of by the class loader. Am I clear with this, guys? So class loader is going to perform three actions: loading, linking, initialization. Online students, kindly respond. Am I clear with this? Online students, I want you to please respond in the chat, guys. Please respond in the chat. I want you to please respond. Am I clear with this? Very good. Very good. That is good. All right. So let us just go with this class area. So guys, please tell me how many memory areas are present inside JVM. How many memory areas are there? 5. In JVM there are 5 memory areas are there. 5 memory areas are there. Okay. So what are those 5? What are those 5? First one is class area, heap area, stack area, PC registers, and native method stack. So let us try to understand what is this class area. I mean what will we store inside this class area? In heap area, in stack area, PC registers, and native method stack. Okay. Class area. What will be stored inside class area? Inside class area, just let me try to write it on the statement here. Guys, first listen. Please don't write when I'm explaining. Please don't write. Listen. Enjoy the class. Now, inside class area, metadata of the class will be stored. What? Metadata of the class will be stored. Sir, what is that metadata? Metadata means data about the data. Metadata means data about the data. Okay. We are understanding it, but little bit confusing. So, see, guys, it's very clear. For example, generally in our demo classes, when I'm giving you some tasks, I asked you how many methods are there. Did you remember my question? How many methods are there? How many objects are there? How many variables are there? I hope you understand me, right? So, in a Java class, how many methods you have created? How many objects you have created? How many variables you have taken? How many blocks you have taken? All that information about the class is known as metadata. Metadata means data about the data. So this complete information about the class will be stored inside the class area. Now, please tell me how many memory areas are there inside the JVM, guys? 5 memory areas are there. First one is class area. What will be stored inside the class area? What? Come on! Metadata of the class. I mean, don't simply say metadata. You need to say inside the class area metadata of the class. If anyone asks you what do you mean by metadata, metadata means data about the data. Means, for example, inside a class, how many methods are there, how many variables are there, how many objects are there, how many blocks are there, how many node statements you have written. All the information about the class will be stored inside the class area. I hope it's clear, guys, for everyone. Okay, now heap area. What is this heap area? Okay. Inside heap area, guys, this is actually very important memory part. I'll do one thing. Every Java class object will be stored inside the heap area. One more time. First listen, please listen. Inside the heap area, what will be stored? Every Java class object. You already know how to create an object. Please tell me if I want to create an object first, what I need to write. Come on, new keyword. Blindly remember this. Whenever, wherever you are writing new keyword, an object will be created inside the heap area. Where it will be created inside the heap area. Now, guys, one more time. Right now, we are discussing about internal architecture of JVM. Internal architecture of JVM. In JVM, we are having a special memory area known as heap area. Heap area. So, what will be stored inside this heap area? Inside this heap area, every Java class object, whatever the object which you are creating in your program, sir, I am creating a 100 object. All those 100 objects will be stored inside the heap area. Now, guys, after explaining our today's concept, I am going to ask questions individually. I will point and I am going to ask. So, concentrate. Concentrate. One more time. Heap area. Okay. What will be stored inside the heap area? Inside heap area, every Java class object will be stored. Kindly please you remember this point in mind. And one more small point, guys. Here I just want to say small point. That is just a small point. Actually, very simple point. Inside the heap area. Inside heap area, there is one more special memory known as SCP. One more special memory known as SCP. SCP. Inside this SCP means string constant pool. String constant pool. SCP means string constant pool, which is allocated to store only string class objects, which is allocated to store only string class objects. Okay. So I just want you to kindly please keep this point in mind. So inside the area, there is one more special memory known as SCP. So what is SCP? I mean, up to now we never came across this word SCP. Yeah. I mean, it's a fair point. We are going to discuss about this SCP whenever we are dealing string handling techniques. At that particular time, I'm going to ask you this question. See, I mean, just imagine like this. We are having a heap area. Inside this heap area, there is one more special memory. Inside this heap area, there is one more special memory known as SCP. This is allocated only for string class objects. This is HEAPAREA. This is heap area. So what is the speciality about this SCP? Why is it allocated only for string class objects? Whenever we are discussing about string handling techniques, at that particular time, I'm going to say, as of now, please do remember this. One more time. Please tell me how many memory areas are there inside JVM? 5. What are the first one is? Class area, next one, heap area, stack area, PCC and native stack. Inside the class area, what will be stored? Metadata of the website. Don't simply stop by saying metadata. You need to say completely metadata of the class. And what do you mean by metadata, guys? What do you mean by metadata? Data about the data. Okay, please tell me what do you know about heap area? What do you know about heap area? No, hang on. Don't read the statement. I don't want to read the exact same statement. You tell me in your own words what do you know about heap area. You are saying some statements right now, right? This is exactly what I want. Understand the concept. Use your own sentences. Am I clear with this? Now please tell me. Inside heap area, is there any special memory present? What is that? I mean, full form. String constant which is allocated only for storing string class objects. Can you please wait for the SAP concept? We will try to discuss it later. Okay, now stack area. Alright. What will be stored inside this stack area? Okay, I'll do one thing. Let me get back to my program here, please. Okay. Now here this is a method one. Okay, just a simple method. Int a equal to 10, int b equal to 20, int c equal to int c equal to a plus b, after that s y s o c. Come on. S o c. Now I'm going to my main method. This inside my main method. Just let me try to create an object here. New class a dot method. You know I can call like this. Yes or no? Okay, I'm directly call I'm directly trying to call my method like this. And now if I'm trying to exit my program, I'll be getting an output that is 30. Very good. Now, my question is, where 10 will be stored? Yeah, come on. Yes, sir, 10 will be stored in A. 20 will be stored in B. Where A plus B will be stored in C. Perfect data. Okay. Now, what is the output? Tell me what is the output? Right click and Java application. My output is 50. Now, same question. Where 10 will be stored? A. Where 20 will be stored? B. Where A plus B will be stored? No. A plus B will not be stored in C, guys. Only plus A plus B will be stored. Yes, sir. Now my question is, where this A plus B will be stored? Inside stack area. Inside stack area means, guys, listen to my point, please. Listen. Whenever we are executing a method, I repeat, whenever we are running a method or executing a method or calling a method, that method needs some temporary memory to store its data and results. That temporary memory will be allocated inside the stack area. One more time. What will be stored inside the stack area? Whenever we are trying to call a method, that method needs some temporary memory to store its data and results. Where that temporary memory will be allocated inside the stack area. Let me do one thing. For example, I saw the board. For example, what is happening here? Just tell me what is happening here. A method is calling itself. Am I right or wrong? Yes, sir. We are trying to call a method from itself only. This particular concept is known as recursion. What do you mean by recursion? Recursion means if a method is calling itself continuously, That is known as recursion. Let me just try to exit my program. Right click, run as Java application. First, I got some outputs. I'm getting the output. I'm getting, and reread it. Reread it. Stack error. Are you understanding the point here? Whenever we are trying to call the method again, continuously, the memory which doesn't inside the stack area filled up. So that's the reason we are getting an error. Are you understanding the point here, guys? Please tell me. Now tell me how many memory areas are there? Come on. Five. First one. Second one. Third one. Inside stack area, what will be stored? Let me just try to write like this. Whenever we are executing stack area, I'll try to write like this. Whenever we are executing a method, it needs some temporary memory to store its data and results. That temporary memory will be allocated inside the stack area. Whenever we are just let me try to increase the font here, please. Right. Whenever we are executing a method, it needs some temporary memory to store its data and results. That temporary memory will be allocated inside the stack area. I believe it's clear, guys. Everyone respond. Perfect. Now, PC registers. Okay. Guys, PC means program counter. PC means not personal computer, by the way. PC means program counter. Okay. Register. What do you mean by this register? Okay. Guys, generally, we will be having attendance register. Yes, sir. What will be stored inside attendance register? Log time and log off time will be there. I am not speaking about what administration which is used in our colleges. I am speaking about in our companies. So generally when we started once we entered the company, we'll be having RFID tags, right? We'll just try to we'll be having tag here and we'll just try to swap the tag automatically door will be open and we'll be able to go in. Once we swap our RFID tag, immediately our log time will be noted down in the machine. Whenever we are coming out, again we need to keep out that. Then we will be coming out. Obviously, our log time also will be stored. Log time and log off time will be stored inside a register. Can I call like this? Yes. Basically, register means it maintains some log files. Say some more examples like this. Anyway, say some examples like this. Register it maintains some log files. I understand that you got the point, but I want one example from you. Tell me. Any example? Any example? Online students also. Just log files. Attendance, banking. Okay. Banking, guys. For example, did you took mini statement? Recently time mini statement. Yes? No. Evaluate recently. Anyways, whenever you are taking the mini statement, it will be having logs, right? At what time the amount is credited, at what time the amount is debited, or else check your Google Pay or phone pay also. You will be having transaction history. All those are nothing but log files. Now, these kind of logs will be maintained in a register. and that register is nothing but program counter register. Now the question is, sir, you are saying program counter register, I mean PC registers is going to maintain log files. Very good. Which logs? What log files? What log files is going to maintain? Are you understanding my question here, guys? You need to respond. Please tell me. My question is, okay, sir, program counter, okay, PC registers are going to maintain log files. I understand that. But what log files? What log files is it going to maintain? Fair question. Guys, in our Java, concentrate. In our Java, we are having a concept known as multi-threading. Multi-threading. What is multi-threading? Multi-threading is used to perform multitasking. What is multitasking or what is multitasking? Multitasking means performing multiple tasks simultaneously at the same time by a single processor in order to optimize the utilization of CPU. So the too technical. Make it simple. Okay. For example, at a time, I'm going to chat with my wife and I'm going to chat with my mother. Come on. Are you understanding the point here? Respond. One person, I am trying to chat with two times. I'm actually performing multitasking. I hope you're understanding the point here. Respond, guys. For example, whenever I'm coming to office, I will drive the bike and I'll hear music. Like I'll have headset. I'll hear music. I'll try to come to office. Driving and listening music. Multitasking. Like that. So in our Java also, we can perform multiple tasks at the same time. In order to do that, we use a concept known as multi-threading. Multi-threading concept is very excellent concept. You will not understand easily. That's a fact. In entire core Java concepts, three topics will be there, which you will feel little bit interested. In those three concepts, the first concept will be multi-threading. Anyways, wait for it. Whenever that concept comes, I'm going to tell you that. So, multi-threading. Basically, what is the use of multi-threading? Please tell me what is the use of multi-threading? Multi-threading is used to perform multitasking. Okay. Now, I have a question. My question is, let me remove this. Okay. I'm going to remove one thing. Okay. Just let me try to. And here just SYSO. Simply I'm editing Java is awesome. And now, just a simple question, guys. Right now, if I exit my program, you know that our output will be Java is awesome. Very good. Fine. Now, in my program, right now, in my program, is there any thread? Is there any thread? Sir, how can we say that? Why you cannot say that? Sir, why? Because up to now we did not came across multi-threading concept. We actually don't know what is a thread. Yeah. Fair point. I do accept. I do accept. Let me do one thing. Let me remove this semicolon. I'm removing this semicolon. Now let me try to execute. Read. Please read. Read. Exception read. Where in which thread? Main method is a threaded. Yes. You got it correct. Main method is actually a threaded. So more information related to this thread whenever we are discussing about multi-threading, we will try to discuss. But as of now, what I want to say here is, guys, listen. At a particular point of time, which thread is executing in your program. I mean, not main thread. I mean, we can write multiple threads. Okay. Do one thing. Imagine a method as a thread. For example, in our demo classes, I have given you method 2, method 3, method 4, method 5, like that. Listen, concentrate. In our demo classes, I have given you method 1, method 2, method 3, method 4, method 5, like that. Imagine all these as 5 threads. Methods, threads, just imagine. At a particular point of time, which method is executing? Let me rephrase it. At a particular point of time, which thread is executing in your program, that all those log files will be maintained under, will be stored under PC registers. So, let me make it simple. PC register. PC means, what do you mean by PC? Program counter register. Okay, please answer my question. PC registers. What it is going to maintain? What it is going to maintain? It is going to maintain log files. Yes or no? Tell me one more time. Please tell me what do you mean by PC? Program counter registers. Program counter registers is going to maintain. Respond log files. Which log files? Thread log files. At that particular point of time, which thread is currently executing in your program. Now those log files will be maintained inside PC registers. Am I here, yes, guys? Please tell me. Perfect. Let me just try to. It is going to maintain. It is going to maintain the log files of thread. Yes, it is going to maintain log files of thread executions. Not one thread, not two threads, multiple threads will be there. That is the only that concept name is, that concept is named as multi-threading. Wait, please wait. Up to now, is it correct? Now, please tell me. How many memory areas are there? First one, class area. What we should in class area? Metadata of the class. Second one, what we should in heap area? Every Java class has stored inside the heap area. Inside heap area, there is a special memory. What is that? SCC, full form. String constant code. Okay. After that, what is area? Stack area. What we should inside the stack area? I'm sorry? It provides a temporary memory to store the data and results which you are obtaining from method executions. Am I clear with that? After that, what do you mean by CC means? What it is going to maintain? Log files of what? Thread execution. I hope it's clear, guys. Online students, please tell me, am I clear with this? Online students, I want you to please respond, guys. Up to now, is it clear for everyone? Please respond. Perfect. That is very good. That is actually very good. Okay. Now, native method stack. What is native method stack? Okay. Before understanding what is native method stack, let us first try to understand what is a native method. What is a native method? Guys, listen. Native methods. The methods which are not written in Java, but those are used in Java. One more time. One more time. The methods which are not written in Java, but those are used in Java are known as native methods. For example, let us think that he got placed in TCS. Right now, he got placed in TCS in Hyderabad. Now, please tell me what is your native place? Native place. Native place means in which place you were born. What is your native place? Where are you from? You are from Maharashtra. Maharashtra or else any place within Pune, something like that. What is that? Jalgaon. Guys, are you understanding me? He is from Jalgaon. His native place is there, but he is working in Hyderabad. Are you understanding that point here, guys? Please respond. Now, for example, speak like if you ask me, sir, what is your native place? See, my native place is Elor. What? Come on. It's just a word here. Come on. Elor. It's I mean, to West Goa, Elor, West Goa, something whatever it may be. So what I'm trying to say is my native place is different. I'm working here. Are you understanding me, guys? Just like that, in Java also, there are some methods which are not written in Java. Those are written in another programming languages like C and C++. But we will use those methods also in our code. Those methods are known as native methods. Am I clear with this? Respond. One more time. What are the native methods? The methods which are not written in Java, but those are used in Java are known as native methods, and all these native methods are present in a special memory known as native method stack. I believe it's clear, guys. So, please give us some examples. Okay. So, please give us some examples for native method stack. Guys, lot of examples with them. For example, every method present in applet. Applets. Capabilities, applets, things are there, right? Every method present in applet is a native method, not written in Java. But we are going to use that in our Java. In our coding also, we are going to use some native methods that whenever those methods come, I'll let you know. But as of now, my question is, if anyone asks you what is a native method, can you answer? Can you answer? What is a native method? The method which is not written in Java, but those are used in Java are known as native methods. And all these native methods are present in a special memory known as native method stack. Let me just try to write a small point like this. The method which is not present in Java, but those are used in Java are known as native methods. The method which is not present in Java, but those are used in Java are known as native methods. All these native methods are present inside a special memory known as native method stack. All these native methods are present in a special memory known as native method stack. As simple as this. Okay. So now, come on. Just a sec. All right. Now. So how many memory areas are there, guys? 5 memory areas are there. First one, class area, heap area, stack area, PC registers, and native method stack. Tell me what will be stored inside heap area. Every Java class object will be stored inside heap area. Is there any special memory present inside the heap area? What is that? What will be stored inside class area? What will be stored inside class area? Metadata of the class. Okay, metadata means data about the data. Tell me how many actions will be done by the class loader? What are those? Loading, linking, and how many types of variables are there? What are those? Instance, static, and which variables will be initialized at the time of class loading? By the class loader. Tell me what will be stored inside these registers? Log files of thread execution. What will be stored inside the method stack? Native method stack. Simple, all native methods. All native methods. What do you mean by native methods? What do you mean by native methods? Native methods means the methods which are not written in Java, those are used in Java, are known as native method. Last one, please tell me. Stack area. What will be stored inside stack area? Temporary memory. Stack area provides temporary memory to store the data and results which are obtained from method executions. Guys, in interview, please don't stop by saying one word. Means, for example, if I ask you stack area, sir, temporary memory. No, wrong answer. If I ask you stack area, if we say only temporary memory, your answer is wrong. Don't expect interviewer knows the answer. No. Say completely. Whatever the concept which you know, say completely. Please don't think like it's a small concept interview we will be knowing. No. We want to hear from you. It's not like we don't know. It's more like we want to hear. I hope you understand the point here. Am I clear with this? So say completely about the concept which you knew. All right. Now. So yes. Class area, heap area, stack area, PC register and native method stack. After that, in execution engine, we are having two components. What are those? Interpreter and garbage collector. Now, what is the work of this interpreter? Right, guys. Please listen to this clearly. For example, I know English. Fine. I went to one restaurant. Or else, let us think that I went to one small shop. Just a small shop. In that shop, the person is speaking in Hindi. I don't know Hindi. I cannot converse in Hindi. So, what happens? I'm trying to speak in English. He does not know English. I don't know Hindi. He's trying to speak in Hindi. I don't know. So, what's the problem? Like, how to sort it out? There should be a mediator, translator. I hope you're exactly understanding what I'm saying, right? I will inform my translator will inform that person. And he will inform the translator will be informing me. Exactly in the same situation. Guys, yes, Java is platform independent. I'm not saying no for that. And once, guys, please listen clearly. Once we compile our dot file, what will be generated? I mean, once we compile our Java program, dot class file will be generated, and inside that dot class file, what will be present? I see, guys, I want everyone to answer. Please tell me. Inside the dot class file, what will be present? Bytecode instructions. Am I right or wrong? Those bytecode instructions are understandable only by the machine. And you know that JVM is platform dependent. You already know that JVM is platform dependent. So what interpreter will be doing, interpreter will convert that bytecode into machine understandable code. Interpreter will convert that bytecode into machine understandable code, and then JVM is going to check whether all those bytecode instructions are right or wrong. Are you understanding exactly what I'm trying to do here? Guys, please tell me. Now my question is, what is Java? Like Java is compiled or Java is interpreted? What? Both. Java is both compiled and interpreted. Compilation, you already know. Guys, please answer my question. Please tell me. Okay. If you want to see the output of a Java program, how many tasks you need to do? I need answers to me. Please tell me. First one. Who is going to take care of this compilation? How do we know that our program is compiled successfully? Dot class file will be generated. Can we understand the dot class file? Why? It consists of bytecode instructions. Now, whenever we are running our Java program, these bytecode instructions are converted into machine understandable code by the interpreter. Are you understanding what point here? Interpreter is going to interact with every bytecode instruction. It is going to convert it into machine code, and then the JVM is going to execute the program, and obviously we will be getting our output. So my question is, what is the work of interpreter? Interpreter is going to convert the bytecode instructions into machine understandable code. And simple. Do you understand the concept here, guys? Let me just try to write a small statement. Interpreter, it is going to convert. It is going to convert bytecode instructions. It is going to convert bytecode instructions into machine understandable code. That's it. Not more than that. That's it. Interpreter is going to convert bytecode instructions into machine understandable code. That's it. Not more than that. Am I clear? Yes, guys. Okay. Now finally, garbage collector. Garbage collector. What is this garbage collector? Right. Guys, personally, I feel garbage collector is one of my favorite component in our JVM. Why? What this garbage collector will do? Okay. Listen. What this garbage collector will do? Okay. Let me make it simple like this. Guys, did you ever ran out of memory in your phone? Yes. If your memory is filled, what you are going to do? We will scroll, we need to check which images we don't need, which videos we don't need, we need to delete it. Am I right or wrong? It's literally a big task. You already know that. See, once the memory is filled up, we need to see which data we want, which data we don't want. We need to filter and then we need to delete it. But what if I'm saying, if there is a concept which will automatically recognize which you want, which you don't want, and automatically it will be deleted. For example, right now in your messages, I'm not speaking about WhatsApp. I'm speaking about normal Google messages. In your messages, there will be thousands of messages. and you don't need all those, but you need some. You will not delete all. Why? Because you will not select all and you will not delete. Why? Because you are afraid that you may need some messages there. Am I right or wrong? Yes or no here? But what if I am saying there is some mechanism which identifies which messages you need, which messages you don't need, and the messages which you don't need, automatically those will be destroyed. How awesome that will be. Yes, our memory will be saved. I hope you're understanding the point. Exactly the same work will be done by the garbage collector with objects. With objects. Okay. Listen to my point, guys. Please listen to my point. Right now, before understanding garbage collector, anyways, maybe after 1 month or 1.5 months, we'll be trying to discuss about this garbage collector concept completely. I mean, one day, one entire session, I'm going to discuss about garbage collector. Right now, I just want to give a small intro. Before understanding garbage collector, we are supposed to have an idea about garbage collection. Words, terminology matters, guys. Garbage collection. Now, what do you mean by this garbage collection? Guys, garbage collection means, listen, concentrate, not you. Yes, please concentrate. Garbage collection. Garbage collection means it is a process of destroying all unused or unreferenced objects from the heap area. Amazing. One more time. Garbage collection. I am not speaking about garbage collector. I am speaking about garbage collection. One more time. What do you mean by garbage collection? Garbage collection means it is a process of destroying. One more time. Please tell me. Garbage collection. Garbage collection means it is a process of destroying all unused or unreferenced objects from the heap area. This garbage collection is done by the garbage collector. I hope it's clear, guys, for everyone. So what is this garbage collection? How garbage collector will work? Which objects will be destroyed? Which algorithm it is going to use? All these concepts we are going to discuss whenever we are dealing with the garbage collection concept. But as of now, just let me try to write a small point. And that is, garbage collection is a process of destroying all unused or unreferenced objects from the heap area. Garbage collection is a process of destroying all unused or unreferenced objects from the heap area. This garbage collection is done by the garbage collector. This garbage collection is done by the garbage collector, and garbage collector is present inside execution engine. I believe it's clear, guys, for everyone. This is about internal architecture of JVM. So one last time, please, class loader. Let us first start with class loader. Tell me, guys, when you're speaking about class loader, how many actions will be done by the class loader? What are those? Loading, linking, initializer. How many types of variables are there? Which variables are initialized by the class loader? Perfect. Static variables will be initialized by the class loader. At the time of class loading, tell me, how many memory areas are there inside JVM? What are those? Heap area, stack area, PC registers, and native method store. Inside the class area, what will be stored? Metadata of the class. complete. I need complete answer. Please tell me. Inside class area, what will be stored? Metadata of the class. Okay, what do you mean by metadata? Data about the data. Okay, heap area. What will be stored inside heap area? Every Java class object will be stored inside the heap area. Inside heap area, is there any special memory? What is that? Full form. What will be stored inside SCP? What will be stored inside SCP? String class objects. Okay, stack area. What is the use of stack area? It provides a temporary memory to store the data and results which were obtained from method executions. PC registers means program counter registers, which will store the log files of thread executions. Log files of thread execution. What do you mean by native methods? The methods which are not written in Java, but those are used in Java are known as native methods, and all these native methods are present inside a special memory known as, come on, native method stack. Okay, perfect. And after that, we discussed about execution engine. In execution engine, right? Tell me, in execution engine, how many components are there? Two. What are those? Interpreter and garbage collector. Garbage collector. What is the work of interpreter? Interpreter is going to convert bytecode instructions into. It simply acts as a translator, guys. That's it, not more than that. Okay. After that, garbage collector. Before discussing about garbage collector, tell me what do you mean by garbage collection? It is a process of destroying all unused or unreferenced objects from the heap area. Who is going to perform this garbage collection? Dot. I believe it's clear, guys, for everyone. Now, please have this in your notes. Let me just try to. What is our today's date, guys? 26, I guess. Please. 26. Save it. Oh, just a second. I'm sorry. Just a minute. Just a minute. Please. Please. Please have it in your notes. You know, if possible, try to write it by your own. If possible. No pressure. If possible. Understand the concept and frame your own sentences. Satvika, you are saying, sir, interpreter spelling is wrong. Oh, sorry. Just a second. Satisfied? It's a typo, ma. Sorry. Please carry on. And online students, I believe everyone received your Google Classroom. And offline students, there is a scan available outside. Please try to scan and fill your details in the Google form. And almost 120 people have already filled up. Remaining still 100 people are there. Try to please fill it. And the people who filled and submitted that Google form, you will be receiving a mail invite. Google Classroom, you will be getting a mail invite. Most probably by today afternoon only, you will be able to get it. Today afternoon or else by evening, you will be getting it. Just you need to accept it. If you accept, automatically you will be joining into the Google Classroom. So make sure it happens by today. And offline students, the people who did not fill the Google Classroom, please fill it by today. The scan is outside only, it's available. Okay, please try to fill it. Jitendra, Java libraries in the sense all the native methods, native APIs will be present in that libraries. And please don't ignore writing the content. Content is important, guys. And if possible, you understand the concept, frame your own sentences, if possible. Learn the concept such that you should be able to explain it to others. Whenever we write these points, are you understand? That's exactly what we need. Completed? Done? Please write. Right. Take time. No issues. Take time, please. Words. So, I, okay. Tomorrow, just a second. Actually, I thought of discussing about differences between JVM, JRE, JDK. It will take much time, only 5 minutes, but I don't think today it's going to happen. Right now, you are already loaded with this concept. Take a break. So tomorrow we are going to discuss about this differences between JVM, JRE, JDK. And tomorrow we'll be having one more important session, basic questions. There are some basic questions in Java which you are supposed to have an idea of. Those basic questions we are going to discuss. And the day after tomorrow, we are going to start a concept which is day after tomorrow. I mean, today is Tuesday, right? I'm speaking about Thursday and Friday. Thursday and Friday, these 2 days, very important sessions. Why? Because we are going to use those in the coming classes. So Thursday and Friday, wait for it. You will enjoy it, but complicated concepts. So why I am saying right now only because don't miss them. Don't miss the classes. You already know that once you miss the classes, recordings will not be provided. I don't have any access to them. And the best part is you will understand those concepts only if I explain. If you see the notes, you will not understand. If you listen, then only you'll understand. I believe that's it, guys. That's it for today. I hope you enjoyed our today's session. We'll be trying to continue our session again by tomorrow. Thank you, guys. Thank you for listening. Thank you. Girls, sit for a minute. First, after that, you can go. Just sit for a minute. Online students, I hope you enjoyed our today's session, guys. All right. We'll be trying to continue sessions again by tomorrow. Thank you, guys. Thank you for listening. Thank you. Have a great day, guys. See you tomorrow.